Oh, thanks everybody for coming today. I am really excited to talk to you, and I'm also really excited about the Big Bash tonight. Has everybody been to an Atlassian conference before? This is my first one, so I'm super excited to see what they have planned. But before we get to the cocktails, I wanted to talk to you about DevOps, how you can reduce time to market and increase developer happiness by adopting DevOps culture, strategies, and tools. Sound good? All right. So let's jump right in with DevOps culture. In the world of software engineering, there has historically been constant tension between deployment frequency on the development side and site reliability on the operations side. When you have separate operations and development teams, this can result in a tug of war. And you have your operations team always trying to limit deployments because deployments introduce change, which always carries some risk of failure. But your development teams, on the other hand, are trying to deliver value as quickly as possible so they can start capitalizing on improvements. So how do we resolve this struggle? Back in the late 2000s, software development and IT operations communities started raising concerns about this tug of war. They realized that these apparently diametrically opposed groups could work much more effectively if they go backwards in their slides. If they work together as a cohesive unit with a shared set of goals. Only by doing so would the organization reap the full benefits of the rapid development that Agile promised. The term DevOps was coined by Patrick Dubois in 2009 to represent this new way of working. But it's not as simple as just mashing two groups together and telling them, hey, you're now a team. You've heard of Tuckman's model, right? Yeah? Forming, storming, norming, performing, adjourning. We're not going to cover adjourning. But it covers the life cycle of a team. When a new team is created, they don't immediately start working together as a cohesive unit. Often, team members are going to work pretty independently at first because they don't know each other well enough yet to have developed trust. This is when it's important to develop those working agreements, because sooner or later, conflict starts to arise in the group. And this is actually a good thing. It means that your team is starting to trust each other. So it's kind of like when you're first dating someone. You know, you're on your best behavior, you want to impress them a little bit, or at least not let them see how weird you really are. It's the same thing with the team. Until they develop that trust, they don't feel comfortable letting down their guard and being less restrained. So often, and I have hit the back button again. You would think that I would remember this. Okay. When disagreements crop up, it's perfectly normal. As long as you have those team agreements in place to ensure that everyone treats each other with respect and that each person's opinion is considered valuable, you can harness that conflict to drive the collective team to better outcomes. Now, why is that? It's because the knowledge of the collective group is greater than any one person. The genius of the team is in the diversity of experiences and viewpoints that different team members have. So things that are impossible alone become possible together. This is when they start to coalesce as a team, when even the really quiet people start speaking up in meetings, because they trust their teammates to listen to what they have to say and consider their opinion. If you don't have those team agreements in place, you're going to be stuck floundering in the storming phase for a lot longer than you should. And it'll become very difficult to pull out of it if you let a toxic environment take hold. So don't let that happen to your teams. Oh, and one more thing. Teams need stability to develop this level of trust. That means not swapping team members out every other sprint or reorganizing the entire organization every 6 months. As long as every time the team changes, they're going to regress a little bit. But if you are lucky enough to have a long-lived, stable, autonomous team that has developed close bonds, they're going to get to this point, performing. I snuck something in there. Did you notice? Autonomous. What does that word mean in terms of software development? Well, autonomous teams are independent. They don't have to depend on a lot of other teams for dependencies. Ideally, all of the roles and skills that are needed to develop software are encapsulated within the team. Now, this can include product management, architects, developers, quality engineers, CI/CD engineers, data engineers, all of these roles that go into making a great product. But that doesn't mean that each person only fills one role. Someone might be able to serve as an architect and a developer, or you might have a quality engineer who's really good at setting up automation for CI/CD pipelines. The key is to eliminate as many dependencies as possible on other teams while still keeping your team to that 2 pizza size. Do you guys know about the 2 pizza size? All right, it was coined by Amazon, and basically it just means that the team is no larger than can be fed by 2 pizzas. Now, another key element here is value aligned. And by that, I mean that the team is responsible for the entire flow of the value stream to the customer. Suzanne's laughing at me over here. She's thinking about the pizza. That's true, or how large the pizza is, yeah. A classic example of value aligned is an e-commerce solution. So it would include the product catalog, mechanism for adding products to the shopping cart, the checkout. It might also include things like customer tracking to gather data around when customers abandon their shopping cart, because that's really valuable information for the team to have. And finally, autonomous teams are empowered. They're empowered to experiment, learn, and pivot as needed without a lot of bureaucracy. They're empowered to decide how they will work and what tasks to prioritize. And most importantly, they are empowered to decide the best way to achieve the outcomes they've been asked to deliver. This involves a lot of trust that your teams will deliver on their objectives, and I get that. It sounds scary to give up control. But if you empower your teams to be autonomous, you will be astounded at what they can achieve. There's a secret to getting the best results from an autonomous team, and I just mentioned it. Outcomes over output. Simply put, rewarding outcomes over output means you're measuring the right things. Let's take an example. Let's say you ask your development team to create an avatar feature for your community website. You think that customers are going to visit the site more frequently if they can see each other's faces, or at least the cartoon robot faces. So the team takes several sprints to deliver the feature because they needed to implement a new back-end process to optimize and store the images, and an AI solution to identify and block inappropriate images from being uploaded to your family-friendly website. You finally launch the feature, and it results in a very mild uptick of monthly active users over a few months, but then it drops back down. So where did you go wrong? All the effort that went into building that feature may not ultimately produce the outcome that you want. What if instead you ask the team to increase customer engagement on the website? Do you see the difference? In the first, you're telling the team how you want them to solve the problem. And in the second, you're telling the team the problem you want them to solve. How do they know how to solve the problem, though? It's not easy, but it is simple. Experiments. So much like with AI-generated art, you are unlikely to get the outcome that you're looking for on the very first try. Back when I was a website developer, I used to tell people, customers don't know what they want until they see it. But if Agile has taught us anything, and I hope that it has over the last couple of decades, it's that we have to continue to iterate, learning to capitalize on the things that work and pivoting to something different when the feedback tells us we're going down the wrong path until we get to the outcome we ultimately want. And those of you that know me know that I really love dragons. This is the power of experimentation and autonomy. When the people who are closest to the work are also closest to the feedback, they can learn from that data and make the best decision about what to try next, without having to get approval and buy-in from 3 levels of managers or a dozen stakeholders across the company. By making teams accountable to outcomes over output, you incentivize them to learn quickly what works and what doesn't, which naturally leads to a learning-centered culture. The faster you can get feedback from customers, the faster you can learn what works and what doesn't. So let's look at how to get that feedback faster. Almost a decade ago, Google decided to research why some organizations have high-performing software teams and others fall short. Google's research team, dubbed the DevOps Research and Assessment, or DORA, released the first State of DevOps report in 2014. In it, they introduced 4 key DevOps metrics that correlate to strong engineering performance. Those metrics are deployment frequency, which just measures how often you deploy changes to production. Change lead time, which measures how often or how long it takes from the time a developer starts writing code to the time it is released to end users. Change failure rate, which measures the percentage of changes that are pushed to production that cause a failure. And finally, mean time to recovery, which just measures how long it takes to restore service after a failure. Now together, these are known as the Deathly Hallows. Just kidding. They're called DORA metrics. And you'll notice that these are metrics that tie directly to strategic outcomes. Deployment frequency and change lead time point to how quickly you can run an experiment and get feedback. Change failure rate and mean time to recovery tie directly to code quality and site reliability. Remember, you get what you measure, so measure the right things. By focusing on these 4 metrics, your organization can reduce downtime and development cost while delivering value to your customers more rapidly. And while all 4 of these are important, today I'm just going to focus on 2 of them: deployment frequency and change failure rate. By focusing on just these 2 elements, you can build a robust process that mitigates risk and reduces time to market, resulting in faster feedback loops. Sound good? All right. Now, before we dive in, I want to see a show of hands. How long, on average, does it take for changes to be deployed to production in your environment once they're marked done? So raise your hand if it takes at least a few minutes. Should be pretty much everyone. Come on. Now leave your hand up if it takes at least a few hours. A few days? What about a week or more? Okay. Look, no shame if your hand is still raised. I have worked with plenty of Fortune 500 companies that have extensive deployment checks that are required before changes can go live. Now, why is that? They have a CAB, a change approval board that has to review every single change before it is deployed to production. Now, CABs are usually made up of industry leaders across the company's tech stack. These CAB meetings usually don't happen more than once or twice a week because it's expensive to have all of these highly paid people sitting around to give the thumbs up or down on a laundry list of changes. So let's take a look at the impact the CAB has on the fictional Acme company. Acme's development team has developed, tested, and scanned a small change. Let's say they're changing an icon. They've merged it into the main trunk of their repository, and the product owner has signed off on it in the pre-production environment. It's done and ready to release on Monday afternoon. But the change approval board doesn't meet until Thursday. And even after they approve that change, the deployment window doesn't open until Friday night at 7 p.m. So Acme could have gotten that change in front of their customers 4 days earlier if they didn't have to deal with the CAB process. Change management is often a bottleneck for progress. So what's the solution? Do we eliminate the CAB altogether? Heck no. CABs serve a very important purpose. Their primary focus is site reliability. Remember that yellow side of our DevOps loop? CAB is a key player here. Not only do they review proposed deployments in order to identify potential dependencies and downstream effects, but they can also ensure that resources are on hand during the deployment window to address problems that crop up during deployment, such as database or network admins. And having this oversight is critical for major releases of monolithic legacy software. But in an ideal world, those dependencies and downstream effects are already known and communicated throughout the development process. The people deploying the changes would have the ability to resolve any problems arising with the change, because that change would be isolated from other applications and services. It really is possible to achieve this ideal state. How? First step, a loosely coupled architecture. Loosely coupled architecture is a very fancy way of saying that the software is made up of multiple independent services, sometimes called components, that interact with each other through APIs. For instance, let's say you have an online store. You might have a service that allows people to search for products. The search service would then call the product catalog service, and it does so by calling a specific URL, which is the catalog's API endpoint, and it passes along search criteria, such as keywords, in order to get the results. The catalog service then returns 0 or more results back to the search criteria. The search service doesn't care how the items are stored in the catalog, how they get added, removed, or updated. All the search service cares about is that it can send a specific message to a specific URL, and specific values will be returned. The name of the item, the price, maybe an ID number to return a link to the detail page of the product, and maybe a thumbnail image URL. This means that the catalog service can be updated at any time without affecting the search service, as long as the parameters that are sent and the values that are returned stay the same. You can add more product information to that catalog database. You could add customer ratings, or you could even swap out the physical database for something else entirely. As long as the API endpoints don't change and the values that are returned stay the same, the search engine's going to continue to function. So there's major benefits to adopting a loosely coupled architecture. But there's one big drawback: software sprawl. Software sprawl occurs when the number of applications or services in an environment rapidly grows and changes. This makes it really difficult for traditional software management, including CABs, to scale. And it can be a nightmare for engineering teams to be able to keep track of where dependencies lie across all the different services. So how can we solve this? Hang tight, we're going to get there in just a minute. But first, we need to take a little detour and talk about service tiers. Let's face it, not every service is as critical as the next. But service tiers are a great way to manage risk. So I'm going to do a quick walkthrough here of what they are so that we're all on the same page. Now, Tier 1 includes your most critical services. Any downtime for a Tier 1 service is going to have a significant impact to customers or the company's bottom line. Examples of Tier 1 services may be a login service or authentication service, or maybe a credit card processor. That's definitely your Tier 1 service. I saw something on Reddit just a little while ago that Disney's systems were down and people were unable to actually enter the park, presumably because they can't scan the tickets, but I didn't read far enough to find out. But that's definitely a Tier 1 outage. Now, Tier 2 services are still really important to the day-to-day operations. A Tier 2 failure might cause serious degradation to the customer experience, but it doesn't completely block users from using it. So Tier 2 services might include your search engine. While that might be down, people could still probably traverse through the navigation of your website to find products to purchase. Or maybe your order fulfillment service has gone down. And that would be a back-end process that causes significant delays in shipping, but it doesn't actually block people from ordering anything from the website. Now, Tier 3 services have a very minor impact to customers. In fact, they might not even notice it. Tier 3 services might be something like a recommendation service. So you bought X, we think you might like Y. Or maybe it's that avatar display that we talked about earlier. And finally, we come to Tier 4. These services aren't going to have any significant effect on customers or internal business users. Tier 4 services might include something like an automated email failure. So maybe your emails go out an hour later than they would have otherwise, but they're still going out to your customers. Or maybe a sales report failed to generate. Now, no one's saying that sales reports are unimportant to a business, but a short-term delay isn't likely to have a major impact. We have one more point to cover before we move on to tools, and that is the difference between continuous delivery and continuous deployment. Continuous delivery and continuous deployment are related concepts that are often mistakenly used interchangeably. Continuous delivery is defined by Google as the ability to release software quickly, safely, and sustainably on demand. It does not mean that the software has actually been deployed. Rather, it means that the main trunk of your repository in your staging or pre-production environment, or a container, if you're using containers as deployment artifacts, must be ready to be deployed to production at any time. Any testing or scanning that needs to happen before your code is released must be done prior to the code being merged into that trunk on staging or packaged into the container in the deployment-ready state. You may be practicing continuous integration and continuous delivery and still have a regularly scheduled release window where changes get manually deployed from staging to production. Remember change failure rate? This is how we move the needle on that metric, by ensuring that the code is fully tested and deployment ready before merging it to that pre-production environment. Now, continuous deployment takes this one step further and automates the release to production. It doesn't mean that as soon as the code makes it to that staging environment, it is immediately released to production. It might still be something that happens on a schedule. Maybe you have an automated deployment that runs at the end of every sprint or at the end of every business day. The important thing is when you have a continuous integration and delivery pipeline you trust, you could actually deploy changes as soon as they're released to staging. In order to have continuous deployment, you must have continuous delivery first. The last thing you want is for an automated deployment to release code to production when your staging environment isn't in a deployment-ready state. Okay, now we can talk about tools. Hopefully you attended the session earlier where some of my coworkers reviewed the really incredible features of Compass, because I'm not going to go through all of that here. And if you didn't, make sure you catch it on demand next week after Team 23 wraps up. But I do want to cover a few key features, that relate to managing deployment risk. Compass provides a comprehensive way to catalog and cross-reference all of the important information about those loosely coupled microservices. Not only can you find details about the service and the team that owns the service, but you can also find data on things like, when was the last deployment and was it successful? What about which services are dependent on this service, and what services or libraries do my service depend on? Another feature of Compass is the ability to create and maintain scorecards for components. Now, scorecards are a way to indicate the health of the service. For example, scorecards might be built to ensure that metrics are within acceptable guidelines. And here's a custom one that I created. In this scorecard, I have change failure rate of less than 10% over the last 4 weeks, and mean time to recovery of the last 10 incidents is under 3 minutes. And if you can meet that benchmark, come and talk to me later, because you're clearly a site reliability wizard and we want you on the team. Notice that these first 2 metrics are ripped directly from the DORA metrics. And there's a couple more on here around unit test coverage and downstream dependencies that also focus on risk management. On the overview page, we're also able to see the service tier. This is a tier 3 service, so it's not really critical to our day-to-day operations. As long as this isn't a dependency of another service, we're probably pretty okay making changes for this service. The risk is pretty low. So let's take a look at the dependencies on this service. Okay, there's no dependencies on this service. This one says it depends on 2 other services and a library, but there's nothing dependent on this service. And the 2 services that it depends on are actually a higher tier than this service. That makes sense, right? Because you wouldn't have a tier 2 service that was dependent on a tier 3 service. If the tier 3 service went down, then it's going to affect the tier 2 service. So in other words, services must be classified with a higher, 1, 2, 3, a higher tier of service than any other services dependent on it, equal or higher, I should say. Now, suppose you're working on a service that has several dependent changes. What if we wanted to deploy changes to production without actually releasing the functionality to our customers? Rather than waiting for all of the changes to be ready to be deployed all at once, you can have each service deploy independently behind a feature flag and then enable all of the functionality at once when you're ready to launch. Feature flags give you a way to minimize risk by allowing you to deploy changes to production in a dormant state and enable them later. Now, feature flags can also be used to disable poorly performing features on your website. Like perhaps there's a spike in traffic and you want to ramp down one of the features that sucks up a lot of processing power. So you would improve the performance by disabling that feature. Or you can use feature flags for A/B testing, marketing testing. Enable it for just a subset of your customers, maybe in one market or across just on one particular node, whatever. This is a great way to get early market feedback without rolling it out to all of your customers at once. So simply put, feature flags give you the ability to have control over when your customers see the feature and decouple that from the process of deploying new changes. But what about continuous delivery and continuous deployment? You have plenty of options to choose from here. We're obviously partial to Bitbucket, but Jenkins, CodeFresh and Circle CI are also great options that integrate with our open DevOps toolchain. So let's look at this all holistically now. When software is designed with a loosely coupled architecture, we reduce the risk of deploying changes to a single service in the application. If we assign an appropriate tier to the service, document any dependencies, and ensure that it meets internal benchmarks with the use of scorecards, we can identify which services are low risk. When the DevOps team is practicing continuous integration and continuous delivery, we know that the code and staging is in a consistently deployable state, having already passed security scanning and unit, regression, integration, acceptance testing, all of that. And with feature flags, we can control when those new features take effect, separately from the process of deployment. And if that DevOps team is held accountable for the end-to-end lifecycle of the service, with the quality of their deployments through tracking the change failure rate, they're naturally going to focus on ensuring that this metric is as favorable as possible. If all of these things are true, there's no real benefit to having the CAB review changes for low-tier services prior to deployment. Even if a deployment does fail, you've ensured that it's only going to have a minor impact on customers or internal business users at the very worst, and it can be rolled back quickly using feature flags. By implementing a continuous delivery process for services with a loosely coupled architecture and documenting risk levels and dependencies, you can create a set of standards for pre-approved changes that will unlock the ability to deliver value to your customers faster. As a bonus, you also free up some of those expensive resources, reducing the amount of time that people spend in CAB meetings. And finally, by enabling autonomous teams that are empowered to solve business problems by focusing on outcomes over output, we can ensure that they are incentivized to learn quickly from mistakes, take ownership of the success of the application, and create fast feedback loops. If you only take one thing away from this session, I hope it's this. You get what you measure, so measure the right things. We've really just scratched the surface of DevOps here today. We didn't cover planning or security, monitoring, integration across tools, automation, none of that fun stuff. But you know that at Atlassian, we are invested in helping your teams work better together. And to that end, we've created an open DevOps toolchain that seamlessly integrates popular tools with Jira Cloud. Jira is the hub. And the advisory services team, as well as our partners, are here to help you make the most out of your DevOps tools and to provide guidance on process improvements. One of the things that we are launching at Team 23 is our new toolchain optimization service, which involves an advisory services DevOps specialist interviewing your teams to get an overview of the tools and processes you use to develop, deploy, and monitor services at your organization. The specialist is then going to analyze that information and develop and present you with a tailored report that includes specific recommendations for actionable changes that we believe will result in greater developer satisfaction and productivity and improved business outcomes at your organization. Sounds pretty cool, right? If you're interested in learning more, please scan the QR code and send us an email to get some more information on this service. Or come by the Atlassian Enterprise Hub, and we would be happy to talk to you about it. Lastly, if you have any questions about Compass, join one of the upcoming office hours sessions. Meetings are held weekly across multiple time zones. So thank you so much for listening to my talk today. And now I'm going to throw it open for Q&A. What questions do you have for me? Yeah. Yeah, just in case anybody missed the toolchain optimization service. Yep. I'm sorry? It does, but honestly, it's a pretty nominal cost. So definitely check it out, get some more information from our folks.
Is it only available to enterprise customers?
I'm sorry, what was that?
Is it only available to enterprise customers?
No, absolutely not. You don't have to have an advisory services rep right now, no problem. Yes, as a matter of fact, it is. We ran our beta test on a customer in Australia. Yeah. Awesome. Well, I know you guys are anxious to get to the cocktails. Yeah.
The data that Compass reports on, are those manually updated? Question is on the data that Compass collects and visualizes. Is that data collected manually? Is it updated manually? Are there processes that...
Yeah, on the scorecards, it can be, or you can actually create hooks into other systems like GitHub and so on, that using Atlassian Forge to pull that data in automatically. Yeah.
So the feature flagging request, is it something that's built into the Compass, or is it coming from Launch Darkly?
So it's not built in to Jira or Bitbucket, but as part of the open tool chain, I know that Launch Darkly is one of the ones that, that hooks in very easily. Yep. Anything else? All right. Thanks again.